We're going to start section 2.3, and this is the sheet that you want to be referring to. This is going to cover almost the rest of chapter 2 here, everything that we're looking at. So right now, things that you should be aware of, you should be aware of just the general idea of where the coordinate plane is. You should be aware of this slope-intercept form, y equals mx plus b. And the rest of this we'll kind of walk through as we're going along, trying to look at all these different lines, trying to write equations, trying to change things using point slope form, trying to how to find slope, how to do all the different looks of these lines. But right now, these are the two things that we want to really be concerned about. So you need to know what slope-intercept form is, and you need to have a general idea of what the coordinate plane is. These 1, 2, 3, and 4 are called quadrants. Okay, so this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, there's 4 parts of it, quad, and rand being the section, so 4 sections. In this coordinate plane, this point right here is called the origin. So we want to know that when I'm saying the word origin, that I actually mean this point right here, which is 0, 0. From the origin, if I go to the right here, I'm going a positive x. If I go to the left, I'm going a negative x. If I go up, I'm going a positive y, and if I go down, I'm going a negative y. Every point that we're going to be making for forever, it is going to be an x comma y point. So whatever I have in the first place is going to be the x value left and right, and whatever I have in the second place is going to be the y value up and down. So let's just keep that kind of in the back of our mind, and then take a look at this slope-intercept form, y equals mx plus b. And we'll deal a little bit more with the slope and y-intercept part later. Right now, well, we just want to go and solve for y. Now, this is review, number 1, because it's from Algebra 1, but number 2, because we solved literal equations earlier. This is just a specific type of literal equation. Okay, so when I go through, my goal is to get the y by itself. Okay, so for some people it's easier or better for them to box that so that they know what they're trying to get to. So things that I need to get rid of, really in this problem I need to just get rid of this 3x. So I get rid of 3x by subtracting 3x. And so I get y equals. Now think back to just a moment ago where I said that this was y equals mx plus b. Okay, so the x part of that is first. And so, yes, I could go 4 minus 3x, okay, because I can't actually subtract those because they're not like terms. But I really want to stay with this theme of y equals mx plus b and put the x first. So this is negative 3x. This was a positive 4, and so I'm going to put a plus 4 at the end of that. And now I've solved for y, and that problem is actually done. Okay, now I want to go to the next one. Here's the y value. Okay, and things that I need to get rid of. I need to get rid of the 2x, and I need to get rid of the 3. It doesn't necessarily matter which order you get rid of them, but if I am trying to get rid of the 3 first, I'm dividing by 3, which can eventually create fractions. Okay, and so if I don't like fractions, that's not where I want to start. Where I want to start is subtracting the 2x, because by subtracting 2x, I'm not actually creating a fraction here. So 2x minus 2x goes away, and I get 3y is equal to, again, yes, you could go 12 minus 2x. You cannot subtract them, actually, but you could put them there, 12 minus 2x. But I want that x portion to be first, so we're going to practice doing that. It's minus 2x. This is a positive 12, and so I'm going to put plus 12. Now, I still eventually had to get rid of that 3 that was in front of the y, and so I'm going to divide by 3, because 3 divided by 3 will cancel out. That'll get me the y by itself. But if I divide that by 3, I have to divide everything by 3. So I get negative 2x divided by 3. I can do the numbers negative 2 divided by 3, and then put the x at the end of that, or I can do negative 2x over 3. Either one of those is just fine. And then I have 12 divided by 3, which is 4. Now the y is by itself. I have accomplished what the equation asked me to do. But let's run down here a little bit farther and deal with one that is maybe a little bit trickier. let's go with, let's say number 7 here. So I'm still solving for y, so this is what I want to get by itself. I need to get rid of the 4x, and I need to get rid of the negative 12. Okay, so I get rid of the 4x first by subtracting it. So I get negative 12y, don't lose the negative. It equals negative 4x plus 36. Now I'm going to divide by the negative 12. Negative 12 divided by negative 12 goes away. I get the y equals. Negative divided by negative makes a positive. 4 divided by 12, well, yeah, I could write 4 divided by 12, but I want to be a little bit better of a mathematician than that and say that 4 over 12 can reduce, because 4 will go into 4 once and into 12 3 times. So I get 1/3 x. A positive divided by a negative is a negative, and 36 divided by 12 is 3. So I get y equals 1/3 x minus 3. Now we're going to be doing a lot with these equations that look like this y equals mx plus b equation. But the first thing that we have to be able to do is get the equation to look like that. Okay, so that's what we're practicing in this section. When I look at this graph here that I'll flip around, you'll notice that the first two problems, this one and this one, are actually the same. And that's because we can do both of them. We can do them in two different ways. And so I'm going to show you the two different ways that we can solve these. But I'm just going to take these two and put them on separate pages over here. So going through and solving these, you can solve any of these equations or do any of these problems that we're looking at by doing one of these two ways. So here's the first one. So this would, for example, be the upper left portion of your graph of your worksheet. And the first way that we can solve these is do exactly what we just did. We can go through and we can go and solve this equation for y. So I'm going to subtract 2x, and I get 4y is equal to negative 2x plus 8. And then I can divide by 4, and I get y is equal to negative 1/2. 2/4 is 1/2 x, and then 8 divided by 4 is 2. Okay, so then that's going to be the equation that I'm going to plug in here. Y equals negative 1/2 x plus 2. Okay, those two equations are the same. And it's actually the same as the top equation, which is why we have the second problem, because you could skip all of that work, and you could just put that equation in the second problem, and that's the reason for the difference between the two. Okay, and so then we'll go and we'll check, yeah, and you can decide which one's easier for you. Ultimately, I'm going to ask you to do both of them as we are continuing through this process, but we'll take them two different steps at a time. But this is a flashback to just the basic idea of graphing. So well, we're going to just pick some x's. You get the opportunity to pick the x's. Now, there's some rules that you might want to follow and before you just start randomly picking numbers. Okay? And so if I'm going to pick numbers, I want to pick numbers that are going to come out nicely for me. And so things that are going to come out nicely, almost guaranteed a 0 is going to come out nicely. There's almost no question about that. Anytime that I am going to plug in a 0, things start canceling out. I don't have to actually add things because I'm adding nothing to them. So 0 is going to be a good number for us to try to use. Other numbers that would be nice are going to be dependent on what's in front of the x. So if I look in front of the x here, I've got a negative 1/2. So I want to plug in numbers that are going to cancel out with 2 that I'm going to be able to take half of. Okay, so I'm going to be able to take half of 4. I can take half of 8. I can take half of 100, but my grid doesn't really fit that. I only have up to the number 7 on here. So I can pick any even number that I want to. If I picked an odd one, it's not the end of the world. All right, if I picked an odd one, I'd get negative 1/2, and I could do half of like 3. Half of 3 is 1.5. There's no issues with that. I don't have to be scared of it. But if I can rig this because I'm picking the numbers, why would I choose to do that? Okay, so I'm going to pick some even ones. I'm going to pick negative 2 and positive 2. All right, this is what happens when we're going through these problems. I'm going to take that value that I chose, and I'm going to plug it in for the x value. So I get negative 1/2 times 0 plus 2. Now, some of you can just do that in your head, and you'll be able to figure out what the y value is. Okay, but some of you are going to need to take this down onto a separate sheet of paper and do negative 1/2 times 0 plus 2. And say, well, negative 1/2 times 0, anything times 0 is 0, and 0 plus 2 is equal to 2. So this is equal to 2. And so I had x was 0 because I chose it, y was 2 after I did the work, and I have an ordered pair of 0, 2. Then I'm going to do the next one, so I get y is equal to negative 1/2 of negative 2 plus 2. Some of you are going to be able to do that work in there. Some of you are going to pull it out and do this. Negative times a negative is a positive. Half of 2 is 1. 1 plus 2 is 3. So I have y is equal to 3. My x was a negative 2. My y is a 3. The third one, y equals negative 1/2 of 2 plus 2. Some of you can do that on the sheet, and that's fine, but here's the work to it. Negative times a positive is a negative. Half of 2 is 1. Negative 1 plus 2 is 1. So I end up with the x value was 2, the y value was 1. Okay, don't take this for granted that you can actually solve it without doing the work. Go ahead and do the work. There's no reason that you shouldn't be getting these problems right. Well, we're doing the same type of steps each time. So now I'm going to graph this. I have the point 0, 2. So 0 on the x and 2 on the y. Then I have negative 2, 3, so negative 2 on the x and 3 on the y. Then I have the point 2, 1, 2 on the x and 1 on the y. Now I am making a straight line. Okay, this is what's called a linear equation because I've got just a plain x and a plain y. Okay, so the x to the first and y to the first, this is a linear equation. I'm making a straight line. So if you are not making a straight line, you are not doing this properly. Okay, so you have a complete check in there that automatically tells you whether you're doing this right or not. Okay, so I'm going to draw a straight line in here. I'm just going to connect the points, and then I'm going to grab it and make it a little bit bigger. Okay, so there's the line. You should draw the line in. It goes on forever, so you can, whoops, that's not what I wanted. You can go ahead and throw the arrows on at the end if you wanted to, and that would be fine as well. Okay, so now there's the work for that one. You can go through it, do the rest of the problems in that manner. Otherwise, here's the work for this. So I still can be strategic about the things that I pick here, but I don't have the foresight that this is going to be a fraction because there's no fractions in here. And so when I look at this, I might end up saying that that this fraction or this problem maybe could use a 1 and could use a 2, and so maybe those are the numbers that I choose. All right, so what I'm going to do is I'm plugging those in for x. So I plug in 2 times 0 plus 4y is equal to 8. Okay, now ultimately that work rate there is not y equals. Okay, so y does not equal 8. I need to go and do the work on this one. I need that extra space, so I have to come out of here. So I get 0 is equal to 4y. 0 plus 4y is equal to 8. So I get 4y is equal to 8. Divide by 4, and y is equal to 2. Okay, and so I ended up the x value was 0, the y value was 2. Okay, and so that's going to this way is going to require a lot more work at the end of this. So I didn't do very much work to make the equation, but I'm doing a lot of work to figure out what the numbers are. So then the second one here is going to be 2 times 1 plus 4y is equal to 8. So 2 times 1 plus 4y is equal to 8. 2 times 1 is 2 plus 4y is equal to 8. Some of you like solving these nice friendly equations, so there's nothing wrong with doing that. 8 minus 2 is 6. Divide by 4, and y is equal to 6/4. Well, most of you are going to do that on a calculator, and you're going to end up with a decimal. I'm going to reduce it first. 3/2 is 1.5. So we end up with y equals 1.5. So x was 1, y is 1.5. Okay? It's still a point. Just because you end up with a decimal doesn't mean anything. Okay? We're drawing a line in here, which means that every single point that you choose is going to actually work. Okay, that's what the line's telling us. So the next one I'm going to do 2 times. I want to make a parentheses every time. 2 times 2 plus 4y is equal to 8. So I've got 2 times 2 plus 4y is equal to 8. This is 4 plus 4y equals 8. Subtract 4 from both sides. 4y is equal to 4. Divide by 4. And y is equal to 1. So I end up with a point 2, 1. Well, again, if you notice, we're doing the same exact problem. So I should end up, when I plug in a 2, I should end up with the exact same point that I plugged in or I got from the equation before. So I've got these ordered pairs, 0, 2, 0 on the x and 2 on the y. 1, 1.5, so 1 on the x and 1.5 on the y. 2, 1, 2 on the x, 1 on the y. Okay, so I end up with the same straight line. If I could take these 2 pictures off of here and put them on the same graph, I would end up with the exact same line here. Okay, so there's the line. I'm just going to make it a little bit bigger. And I end up with the same line because I'm doing the same problem. I should end up with the same line. Okay, so whether you do it the y equals mx plus b way or you do the problem this way, it doesn't matter. You should end up with the same thing. Okay, go through, do these problems, take your time. It's easy to make mistakes when we're doing linear equations, but this is going to be the long version. So anytime that you get to a graphing problem and you don't know how to start it, in the rest of your mathematical career, this is the way that will work every single time.